we're more than halfway through. We completed the coding. I know many of you are good. You learned a lot, right, Peter? Oh, by the way, before I forget, I think many of you probably received the invitation from me, right? Join us cyber skill competition. If you don't receive, it doesn't mean that you are excluded, but I sent out that invitation from top of my mind, assuming that you like some implementation work. So I ask you to propose the first kick-off meeting date. I think I gave you a few days, right? Few options. So you can choose as many options as you will be available. Okay, so that I can pick one of those. As I said, I received a grant from the colleges, so a little bit of refreshment continually. So we will have a weekly meeting. Weekly meeting will be decided at the first meeting, which is a kickoff meeting. During the semester, probably we need to meet on Saturday, but after this spring semester is over, we may be able to meet some other evening, right? Or afternoon. The idea is that we gather together, sit down, and discuss about the project, meaningful projects. And then we form a group, multiple groups. You may bring the team of yours to that meeting, but if you do not have, then you can still join and see who are available. So you can form a competition team. And also, once we pick the topics, so each team has different topics, right? Then we need to define the scope of implementation. Some implementation may need some something to purchase. I also had small money that we can buy. Okay. For example, if you want to buy some microcontroller units, some sensors, some antenna, wireless antennas, and things like that. And then we can purchase for you to conduct your research. Okay, and some of the devices and the software that you have to learn, then we can also together to study. Okay. If you, as the competition activities go on, I know that some students some group might have some difficulties, okay, some obstacles, some problems. Then we can work together. That way, all of the participants can learn, can gain significant skills at the end. So that is very, very important.
Those meeting, these dates that you gave us, so in order to come to talk about.
That is the first meeting.
Progress.
Well, that is the first meeting, and on that first meeting we will decide when we are going to meet regularly.
For those who's not able to come onto this day,
Which one do you, that you can make?
I have a full schedule. But can we, for example, like before class today, like at maybe it's at 2 p.m. or after class or between classes, I show you the progress of my project, and then we go from there, and then just using emails.
That's also possible. Yeah, that is also possible. Yeah.
Not all the days. I mean, if I'm
Right.
able to have an off day and to assist,
Mhm.
so we're able to do that.
Mhm.
Okay, that's good.
Okay, back to our class 505. So we looked at the coding skills, and I hope you. It is not really. There's no magic that you can gain coding skills in 6 weeks. But the thing is this. I mean, within that short time period, if you learn some, then that is itself is a miracle, right? So from that miracle, you can go forward to gain a great improvement. I am sure that you all can do. So what so after the coding, we looked at network, right? So where is network? Yeah, I think this is a network. Okay. So today we will finish up network. We'll do a little bit of Python coding. How Python can sniff the network packets. So when you look at the packets, network packets, it is a pact, which means although you see the code, it is not really readable. So what you need to do is that you need to unpack it. So a little bit of coding skills involved. So before we get to that unpacking the packets, we'll look at a little bit of the coding skills also. That coding skills will be not necessarily to this network, but in other applications that you can use. So that is very, very important. Hopefully that we can finish up the network, then we will switch to another module, which is operating systems. So actually, operating systems and database systems are very similar, very, very similar. In general, many cases we call it system issues. If you work on database, if you work on operating systems, they're all system issues. So many of the universities call it system, okay? So when it's system, it means operating systems or database systems. Network is not called systems, it's network. It has totally different concept. But the concepts discussed in operating systems also discussed in database systems, vice versa. Only difference between those two primarily on the granule of items that those systems are considering. For example, operating systems consider the files. Anything that operating systems concerns is files. Anything that database system concerns is not necessarily files. It could be it's a multi-granules. Sometimes it can be one cell value. Sometimes it can be one record. Sometimes it can be a one table. Sometimes it can be a file which can contain one table, or file which can contain more than one file or one tables, or sometimes file which contains a part of a table. If a table is really big, like a table used in big data, then big data table is not stored in a table, which can be split into multiple tables, multiple files. Okay, so let's take a look at network in Python. Network in Python. Let me bring this a little bit up and a little bigger. Okay, here. All right. If you look at this, see here, in this section we will discuss about client-server Python program and a socket interface based on packing data analysis. In Python scripting of any cases, sockets need to be fully understood and properly configured. When you sniff the packets, network packets, then you need to open up the sockets. As I said, socket is a port from which the network cards receives network signals. Okay. So we need to tap into that socket and read the packets. Each operating system uses different socket families. So I want you to read this text that I posted on, I think I posted this on sitesecure.org, right? I redirected from your Blackboard to the sitesecure, so you may be able to see that. AF underscore Unix, AF underscore init, netlink, TIPC, and so on and so forth. One of those socket family needs to be used, and if you see here, then there is AF family and PF family. AF refers to address format family, while PF refers to packet family, packet format family. So AF inet, this is actually that we are usually uses a host port pairs. Okay, host port pairs. So it'll be a list of host port pairs. All details can be found in this library, and also some of the member values can be found, and some of the functions can be found also. So if you need to see this, then we can still look it up.
Okay. So this is very, very important source that you may like. So this is a socket family, as we look at, and some of the information can be found. And also socket-related functions can be needs to be used in our program. One of actually, this is like a function like the constructor. So that we need to create an object of sockets by calling socket function. So if you say socket, then the first argument for that function is the family, socket family, and socket type, and protocol, and file length. Actually, 4 elements are used, but usually we may be able to see, enter 3 elements, not necessarily for all. And another thing that you need to look at is another function is the socket pair, and socket.create connection, socket.from FD, and there are many others. Here socket.get host by name, get host by address, get name info, get protocol by name. Many useful informations that you can gather once you connect it to the sockets. And socket methods. Another function that you may be able to use is a socket bind, socket.bind. This is something that we used, right? Socket.accept. When we look at client and server implementation, then we looked at some of this. Socket receive from, socket and send, receive, many others. So client and server programs that we looked at last time, UDP and TCP. Remember that we did it differently. You can set up UDP and UDP server and UDP client that we looked at last class, and also TCP server and TCP clients, right? So depending upon your application requirements, you can set up for TCP, client and server, or you can set up UDP, client and server. So 2 types of settings here. Did I ask you the homework assignments, new homework assignments?
505?
505. No, nothing from network. Okay, so we'll do that either do you like sniffer implementation or client and server implementation? Sniff. It needs a lot of work. We're not going to do all of those, but I'm going to wake you up a little bit so that you can do your own. This is a sniffing. The section 4.5.2 network sniffers, network packet capturing. In this section, we describe how Python scripts can access network interface cards and extract raw socket data to interpret. Recall a socket object is constructed by socket.socket that we looked at. So the object of UDP or socket object of UDP or socket object of TCP may be able to be constructed. Okay. In this case, the socket type, remember that if you set up TCP-based client and server, then you need to do TCP socket. Socket UDP is socket. Let me take a look at socket. Socket DRAM, sock DRAM. If you want to set up UDP, if you want to set up TCP, then sock stream, right? See here, sock stream, sock underscore stream, or sock UDgram. But in socket, packet capturing programming, we need to use sock underscore raw. So we need to receive the raw socket data. That's what we need to do here. Okay. Please note that the access to socket data require administrator privileges. This is very, very important. Administrator privileges. If you're working on, doesn't matter, Mac or Windows, particularly if you are working on Windows, then you need to run this program from administrators. Okay, so we'll look at that. The steps that you need to consider is acquire network interface. Of course, you have to identify the network interface. Otherwise, network packets cannot be captured, right? So you need to understand the network interface installed on your laptop. So hook into that network interface and then capture the packets. And then create an object of raw sockets and bind the socket object to the network interface obtained above. See here, we have a network interface, we have a socket, and then we bind them. Okay? And include IP heads, receive all packets, receive a packet header. It has a header, and if you receive all packets, it has a packet header and packet data. So we will take a look at the very simple codes can be found here. Okay, and I want you to practice this. This is already explained. I put there the comments so that you probably can understand. So before you do that, I'm going to give you a quick demo of mine. Oh, wait a minute. Yeah, before we do, we have to understand a little bit of I want you to practice this first. Okay, and you have to see how it works, and then we can look at some technique, coding techniques. What I want to show to you So I have a multiple sniffing code here, so that I can have Python 36, Python, and then sniff for 4.py, for example. When I do this, to see if I have that program. Yeah, I do have that program. When I run this, there is an error that we expected. The error here is that an attempt was made to access a socket in a way forbidden by its access permissions. If you look at that error messages from the Google, then there are a lot of noises. Okay. One of the simple ways that you can resolve this problem is to run this one from, as I said, if you have here a command line, then there is a run as administrator. So click that. This is run as administrator. So we do the same way that we did. Sniff for 4. Okay. If you run this, so some of the packets are interpreted. Not all of the packets that you can see, for example, from Wireshark. Okay, you can do this if you run this within for loop. I didn't make this a for loop. So one time, at this particular time, it hook up the network interface card and capture the packets at that particular time in point. So if you look this, see a host info from this function, get host name. So 172.25.56.61 some. And then get fully qualified domain name is this is mercy.local. And I have 3 of those. And then TCP header in byte code from here there. And then unpacked data 69040 whatever that. And then I interpret it. So in your first program, I want you to look at this raw data first. This is raw data. So once you receive this raw data, then we need to look at another the packet structure. Packets are, there's a standard. So that all the TCP packets are formed in that rigid format. And also in C no, not in C. In socket library and also Python, there is a struct, the module. The struct module is very similar to the struct in C programming. Those who know the C programs, then you know the struct, right? So packets are formally structured. So when you unpack the packets, then you need to look at the way that it is structured. Okay, in the same way that we'll look at that here. Okay, so the first step that you need to understand is run this program, simple. And then we need to look at another. Okay, so try this now. Just copy the way it is written. If you see that there is a get host name,
Where did you post this file? The module? The coding module?
Text.
Text?
Text which one?
These three networks.
Yeah.
course I mean the last item in the course materials. The item in that the posting that is in the chronicle order. So earlier comes first, the recent ones. So now you know here. See, yeah, packet header or packet data is all binary code, right? So we have to now understand how to manipulate binary code. Binary code can be generated from the module that we need to practice right now. So I want you to go back to user interactive mode. There you can run Python so that you have Python prompt triple greater than sign. Okay, can you have that? There, what I want you to do is to import struct. Import struct. No, from struct import everything. From struct import everything. So we import everything. And then there is a the function called the pack. So we need to pack. I want to pack HHL. Oh, what the hell that HHL means? Then you need to come back to the library. Python, this is a module. Python, see here, 3 dots. If you look at this, 3.6 library, struct.html. Scroll down a little bit. And there is a byte order. Native byte order. If you have less than sign, a little endian, big endian. If you do not understand what that endian means, then you have to. We don't do it here, but look it up from the Wikipedia, that you can fully understand what Indian system means. And then here, format characters. When I say HHL here, this is not one. HHL, small h means there is a short, which is integer. So that is the 2 byte long integer. Can be formatted by h. What we are going to do that here is, I'm going to pack the value, for example, 1, 2, 3. I want to pack 1, 2, 3, but first value 1 in 2 byte, second value 2 is in 2 byte. L means then that is long, which means 4 byte long. Okay, doesn't matter. You can do pack. Okay, so let's say 10, number 10 in 2 byte long, and number 21 in 2 byte long, and number 3 in 4 byte long. If we hit enter, then not pet, pack. Okay, so what happens here is that 2 bytes. This is hexacode. This is a byte raw data. Hexacode 00 and 15 together. If 15 in, wait a minute, 15 in hex, that is, let's first take a look at this. This is 2 bytes for 10, and right, 2 bytes for 21, and 4 bytes. 1, 2, 3, 4. Let's make it simple. Let's do this. Oh, I see. So 1, 0, 1. Just 2 bytes, and 2 bytes, and 3 bytes. This is a high endian. So endian means, let's see, if we do little endian, big endian. So if we do, it's a little endian, it's a little endian, but if we do big endian, okay, if you look at the big endian, then it makes more sense to you. Number 1 can be written in this way. So 0001 means 1, right? In big endian. So that is okay. And 0002, that is number 2. And 00000003, that is 3. That is in big endian. Big endian means the difference here is this. The most significant values appear first. So 01 appears first. The other one is 01 appears later. That is the difference. So low endian and big endian. So in the previous ones that we did here, if we want to make this in big endian, then it'll be like this. Why is it 1 here? And let's see, 11. Okay, so 11 means this makes me confused. So 000B, then that is 11, right? In hex, 11 in decimal, that is B in hex. 21 in decimal, that is 15 in hex, and 3 is a 3, of course. Okay, this is a pack. Okay, so if we make this let's say this. I want to make this, say, my packed. So my packed contains that. And then I want to unpack the way that we did, and then my packed. Then it returns 1, 2, 3, the way that we packed, right? So this is a low Indian, but if I packed this low Indian, but I unpacked it in big Indian, then it gives me a different way of pack, right? The exact same ones, but it returns differently. See here, my packed here, right? It's a 1, 2, 3 is a packed. By default, that is a low Indian. Like this. This is a low Indian. So if I do low Indian, then the way that I packed, I unpack it so that I received the way that the value that I packed. 1, 2, 3 is unpacked. Okay. If I do what is my packed? My packed is this. This is the packet that you received from the code, right? So the way that we do, the way that we receive from the code that you practiced needs to be unpacked. When you do unpacked, then you need to figure out how many bytes that you want to unpack, in what structure. So you have to understand the structure of the packets. See here, what is the structure? I said this value, forget about the value itself, not the magnitude, but the value here. The first value in 2 byte long, second value in 2 byte long, third value in 4 byte long. That is the way, in that structure, my packed is packed. My packed data is packed. So this is my packed data. Because it is packed that way, I need to unpack it the same way it is packed. Then I will receive the same value that I packed. But if I packed it differently, for example, this is a low Indian, but if I unpack it using big Indian, then it gives me these values. Okay, so you have to do it very carefully. Another way that you can see here, rather than this, if you do, for example, LHH, see what happens. That is the value that you will receive. So you have to see here. I want you to compare this unpack and this. They are very similar, but only difference here is that structure, the way it is a character structure. Here I said, hey, I want to unpack this value in this structure. First 4 bytes, and next 2 bytes and 2 bytes. Then I will receive this value. But if you say first 2 bytes, second 2 bytes, and last 4 bytes, then you will receive the value that was originally packed, 1, 2, 3. Do you see that? Okay. This is very useful technique to generate raw data, I mean byte code. Okay, now back to our textbook. If it's a TCP head, TCP IP head, then there's a 5 rows, right? In the first row, each row we have 4 bytes. So we have 0, 1, 2, 3, 4 bytes long. First byte in the first row contains two different information, which means in the first 4 bits for the version of IP, so IP4 or IP6, and next one IHL, some length, and then next 1 byte contains the type of service, and then it follows by 2 byte long the total length of your packets, and then next 2 bytes identification, and then in the next 2 bytes, this is a little bit tricky. In the next 2 bytes, only the first 3 bits for the flags, and the rest will be the fragment offsets. The size of the rest, therefore, will be 8 plus 5, so 13. 13 bits for fragment offsets. And after that, very straightforward. 1 byte for time to live, 1 byte for protocol, 2 bytes for header checksum, and the next 4 bytes for source address, next 4 bytes for destination, and next 3 bytes for option and padding, followed by payload. That is the structure. Packets, if it receives through TCP IP, then it contains in this way. And then packets is packed in this way. So you have to unpack it the way that you do here. So what you need to do here is that when you receive that packet, then by having this, I'm going to explain in another sample coding. Look at this coding. Okay. I want to unpack it. See here, receive the data. I'm sure you did up to this, right? Receive the data. And then we need to unpack it. The way that we unpack is the way that it was originally packed. So when I do unpack, I need to unpack it. First 1 byte, and next 1 byte, and then 2 byte long, 2 byte long, 2 byte long, and 1 byte, and 2 byte long, and then 4S, and another 4S. What do you mean by S? If you come here in the manual, S means here the byte. Size of S means bytes. Byte in character. The character, list of character. See here, list of character. Actually, in C type, it is called array, right? Array of character. So, array of characters in 4 bytes. Array of characters in 4 bytes. So if I push this a little bit up here, and then if I bring this, no, not this, but my text. Where is my text? So bring this, oh, this is my text. Oh, it is in the same what I'm going to show to you, I'm going to leave this here, and instead I'm going to bring okay. So this and that. This is the code. Okay. Okay, perfect. So here first so when you receive that, so first byte that contains the version and the length. And next 1 byte is a type of service. So 1 byte and 1 byte. And next to 2 bytes, which is H, that gives me the total length. And then next to 2 byte long, which is this is 2 bytes identification. And then here we have to read the 2 bytes together because partial of 2 bytes is 4 flags, only 3 bits, and then 13 bits for fragment offset. So I have to read the 2 bytes together. So that means the last H here. And after that we have 2 1 bytes, which means here time to live and protocol, so each byte. And after that we have 2 bytes long head or check some information. So we have this H. And after that we have a 4S and 4S, which means 4 bytes of source address and 4 bytes of destination. If you want to read more, then you need to do 3 bytes option and 1 byte padding, and you can read further and further. But in this program we look at only 20 byte long from the data that we look. Okay. So next practice is for you to do. Is there? Yeah. This. Example 4.5.4. Okay. So practice it. Then you will receive, for example, as you look at in this sample, the version is 4. And then internet header length is 5, which means I read only this. But you can read another B, you can read another 2 byte long and further. Okay? Let's practice. Thing is that the internship, then it shouldn't be related with you're not working, right? So that internship position itself. If it is an internship position, then yeah, definitely it works. Yeah. But some other cases, for example, you are working as a full-time, okay, some company. Can you do that? Can you use your work as an internship? No. That is your work, right? If it is an internship, then
if you do projects in your work, yeah.
No. Here is the thing. Here is the thing. Only the case that you contact to some other supervisor, not your own supervisor, but some other supervisor in the same company who are doing cybersecurity, then I approve that. Yeah, a few of our students did that.
Yes.
but not directly from your
Direct supervisor.
your boss, then that is your work.
Yeah.
Two birds, one stone.
But if you come up with
No.
a new idea, if you come up with a new idea with a new work, I've done an internship like this before. They have a need, then I came up with a new project that's help their needs. It's a prototype for them. Then they
If that is an extra, it's not your right core. If it is not, you do not do that for your paycheck.
How can you know? How can you know?
Your supervisor needs to write. That is the reason that I ask your supervisor need to write.
Yes.
But as an international student, I don't have to work permit yet. If I register 590 and if I get a job from any company related to cybersecurity or related, will it count as an internship?
If it is
it could be the full-time job.
no, internship is not full time.
It could be the part-time.
If it is a full time, then that is your work,
No, I don't know what.
right?
You cannot work until you spend 1 year.
Thing is this.
If I register,
After
I
1 year.
work. But if I register the internship, then I can get a CPT. I can work
This
for
kind of internship is
You need
okay.
1 year. 1 year here.
Listen.
After 1 year, you can request the CPT.
There's an internship during the summer, full-time internship, right? It's not really regular pay. It is you are assigned to a specific top research, specific projects. Then may be possible for your internship. Okay? And it is not your regular job. And your supervisor says this is an internship position, and the work that you are assigned to is cybersecurity related. Then
Mercy College doesn't help to find any internship. I was in university before. They used to help us. Here they give us Mercy Mavericks, and you apply a number in Syria. Even though you have a very
Mercy
good
College, IT, they hire continually some internship. There are some internship.
They send us
Did you-
email.
did you find out?
During canteen, they send us always email. I've been applying and never received any reply for them. Then I give up. I just forward their email directly. I don't see them at all. Because nobody responds, nothing. There's no real people that works on this in Mercy College. It's a big need. I would love to do an internship, but for us international students, that's really hard. Even though we have the skills, we can from tomorrow start a job position without any training and do the job, right? Because I have these skills. Hmm? Okay.
You will have more than 10.
Oh, well.
Oh,
that's Mercy IT.
I'll be good.
Because I know Yosef wants to work on network. Almost all the work that our IT departments are concerning is network, right? All other works like PC maintenance, that's the garbage, right?
Yeah.
That's not the type of work that you are going to look for. But network is a little different. But if you write a very nice resume, you have to explicitly specify there, I want to work on network internship. Start with the internship. Don't worry about it. Okay? Internship. Then I will, because in our IT have some connection, right? I have a connection. I do not have a connection somewhere else, but I do have a connection so that I can forward it. Do this.
It's done.
Done? Oh, you're qualified. So I'll send yours to IT and yours to Roy.
My coordinator. question. I worked more than 8 years in my home country as a networking system
Send
engineer.
to me also.
And started
I'll send
from
two
CCNA.
resumes too.
And started with CCNA, CCNP, MCP, MCSA. But I don't have any work permit. So I can't.
You have all.
Yeah,
So Bangladesh is a kind of a country frequently attack others. I mean, attack means they can defend.
I talked with the marketing CPT department periodically.
Okay, so you did. Who else did this?
So I almost done.
Almost done. So I'll give you 10 more minutes. Done? You have to, remember that as I said, you have to run as a super user. This is a map, right? What is this? Can you run this text regular as a super user? Huh? Oh, desktop? Okay. What's the name of it? There's another right? Arrow test. Okay, I'll give you 10-minute break. Okay, and then we'll. This is the end of network. As I said, my final comments. Look at, see here the structure. So the way that you have, for example, if you want to further unpack the TCP header, then you need to do H. The way that you unpack, the structure that you want to unpack relied on, then it should be H. So H means 2 byte long. That return about your source port, and another 2 byte long, there's a destination port, and 4S, then there's a sequence number, and so on and so forth. The way that you can do this. So unpack, for example, unpack in this way. This is the data that you have. This is the structure that you want to unpack. So you have to do it clearly. Okay? So that you need to see if it is low Indian, then you will have 1, 2, 3. The same one, but big Indian, then you will have different number. Okay, and that way you need to you can get the specific value and information from the packet. Sometimes if you have, for example, 3 bits, only 3 bits for something, then you need to have, for example, bit shift. Okay, the way that that you practiced in the sample program. That's what you need to do. And other than that, I think we'll, okay. Let me see. Do I have here? Okay. That's good. If it is the case. Okay, so what is an operating system? I know you guys know the Windows operating systems, Windows, Linux, some of you, Mac OS, what else? Android, somebody's, iOS. There are varieties of operating systems available. Okay, so what is operating system? Operating system is a program. It's a set of programs that acts as an intermediary between a user of a computer and the computer hardware. Actually, what you need to do at the other end of your side should be some hardware that can do some action, although you are working on your keyboard and monitor. So there should be something in between you as a human and hardware at the other end. Hardware that could be some robots, hardware that could be a printer or network, anything, right? It could be nuclear bomb, North Korea, maybe possible, right? ICBM. So goal of operating system is to execute user programs and solve some problems. If you have a robot which has some sensors on it. By the way, I purchased the robots. Robot could be anything, right? Small toy. There's also robots. In another 555 class, I practiced that already, so you will like it. We can add some sensors on it. It has some sensor already, but I want you to add more sensors on it. So your program can, at your end, you do some programming, and the other end, some actions. Actions can be taken by hardware. Sometimes we call it a robot or some vehicles. Another goal is to make the computer systems convenient to use. So operating systems gives you the easiness of interface between you and computer. One of the the interface between human user and the computer is graphical user interface. When I first learned the computer, there's no graphical user interface, only dialogue based, only command line. 1980s, right? Command line. Of course, Mac users, like Macintosh, at that time, from the beginning of that Macintosh, the personal computer provides the graphical user interface. Meanwhile, IBM operating systems, which is the earlier version of Windows, do not have. Okay. And then late 1980s, when Microsoft acquired the portion of PC components from IBM and developed the user interface, graphical user interface. That time they called that Power PC, Power Windows, something like that. It was not really powerful. How do you know yourself?
I know the story.
Oh, you know the story, right? I'm the witness. And then 1990s, then we have a little bit better Windows systems. Okay, from Microsoft. So easy access to computer. Another goal is to use the computer hardware in an efficient manner. Again, in 555, all of you coming to that 555, I purchased also Raspberry Pi. So probably, depending upon the students, maybe 2 students as a group work on Raspberry Pi. And it is a computer. Okay, you can connect the Wi-Fi.
Does it have air plug? Entry? Plug and Wi-Fi?
You can install it
Okay.
if you want.
How much memory did you have in yours? How much?
I think 1 gig.
1 gigabyte. Can you put more?
You're pretty?
Probably not. It is a Raspberry Pi.
No, the size is the same. It's not
Right.
the
It is
same.
the one chip that has almost everything.
One chip.
Okay. Yeah. One board. So it is not expandable. It's not like a PC.
The maximum is 1 gigabyte.
I think there's a 1 gigabyte. I'm not sure. I'll check. But for example, Arduino Uno, that we are going to work on also. Both of them are MCU. MCU means microcontroller units. Raspberry Pi has bigger and powerful unit than Arduino. Arduino Uno, the memory, storage, everything all together, 256K. Still okay. It compiles your C programs. It runs the operating systems if you want. And also you can save some of the files that I practiced. right? It is
You
an
have
EPROM.
storage, like memory card storage.
External.
Raspberry Pi, yes, but not Arduino Uno. Arduino Uno, you can use only, there's an EPROM, which means you can write and erase, write and override, but there's a limited.
And also network card. You can have a network card. Since you can have a wireless card, you can have a network card.
Network, Raspberry Pi that we purchased has a network card already installed, already embedded. Arduino Uno, I requested to purchase Arduino Uno Wi-Fi, but that version discontinued. So if you want to communicate, then you need to have extra the internet card, extra Wi-Fi shield. But anyway, that we are going to talk in another class. So there is a operating system. Operating systems is running basically on almost all the computers, almost all the microcontrollers, and also small devices like mine. Fitbit, it has operating systems, and it has a network so that my cell phone can communicate with this. I thought this is a Bluetooth communication, but it is not. It's through Wi-Fi. Very stupid way, but that's okay. So structure of a computer systems. You know, a computer has hardware and software in between operating systems. Except the hardware, everything is a software. Operating system is a software. Your application program is also software. What you are going to do is also software. Everything is a software. Hardware then, what is hardware? Hardware is, if you confirm your software runs well, then you can print it. So hardware is also software. Only the software is, if it is a dummy, then that is a software. Jack, adapter, that itself is a software. Other than that, if some device runs a little bit of an intelligent way or some iterations, then it is nothing but software. Okay? Network, almost all intelligent network device, there is a software embedded in the circuits, right? Somebody already programmed it and then print it. So this is the structure of your computer systems. If you look at this, then on top we have the big components, so multiple users. Bottom, we have small components, which is hardware. This kind of pictures drawn, for example, in 20 years ago, then hardware becomes big. It's upside down. And up, there's one single user. But now we have a multiple users running on one small hardware, right? See the size of this? Computer hardware, small, and operating systems, little bigger. And on top of this operating systems, we have a lot of application systems and development systems, like a compiler, assembler, text editor, this is applications, database system, that is application systems. So user can work on the application systems or development software. So operating systems can do a lot of the things that you expect when you have a hardware, computer hardware. This slide is very easy, so that you do not have to. I want you to read. nothing valuable. Operating system definition. OS is a resource allocator and control program. Hardware, your hardware, it has a lot of modules, hardware modules. Keyboard, monitor, CPU, storage, a lot of modules, network. So those modules need to be properly allocated. When user asks some mission to a computer, then operating system receives it and some job scheduling. Hey, to accomplish this mission, then we have to use this resource at certain order. That type of things needs to be done. Operating system is also control. It's for control. A lot of controls needs to be done. Security or execution, communication. Okay, third bullet. The one program running at all times on the computer is called the kernel. Okay, all operating systems has a kernel components. And the size of operating systems is a lot bigger than kernel. Kernel is a core portion of operating systems. So kernel runs at every time. And operating systems becomes bigger and bigger to control, to allocate, to control more management, to allocate more resources so that operating systems gradually upgraded. But kernel remains very similarly almost all the time. Okay, how operating systems runs. Therefore, hardware, your computer as a hardware, becomes something powerful like computer and understand your request, how your operating, your dummy hardware becomes ready for you to request so that provide the solution back to you. It's basically, it should have some operating systems running. One of the operating systems mission is I/O handling. Okay, so it's not here. Okay, the idea is this. Your computer let's say this is a memory, and then you have here CPU. CPU is a processing unit, right? This is a CPU. When you say something is executed, it means that that is processed in this CPU. Okay? Central processing unit needs to take the instruction, say your program has programming instructions. Then needs to be taken care of this CPU. At the other end, you have a storage, right? So disk. From this storage, if you have some programs, that program needs to be here. This program needs to be all the way here in this CPU. Who brings that program into this CPU? Operating system, right? So efficient operating systems can do, or if resources becomes bigger and bigger, then you need to have some other intermediate repositories, so that rather than bring your instructions directly from your disk to CPU, now I want to receive it, I want to load from hard disk drive to your memory, so that we call this memory. So we have to load somehow. Load whatever you want to do that is electronically available in your hard disk should be loaded in your memory, so that your CPU pick up part of your memory component to CPU. In this way, your computer becomes more powerful, right? You don't need to bring anything that you want to from hard disk directly to this CPU. Then very inefficient. Why? Because the speed of CPU is a lot faster than the speed of your hard disk drive. If it is the case, then your CPU wait longer and longer until your hard disk drives searched and find some of the instruction and bring it. So you need to have something in between. There is a memory, right? So some pieces of programs needs to be loaded in the memory, and then frequently this CPU fast access something available in this memory, and memory size is also limited. Then if memory is full, then your operating system needs to swap some space, so that this space, your operating systems preserve some of the space, so that additional application program can be executed. So that type of management and control needs to be done by operating systems. So operating systems can do all the management and all the control. So we understand that, right? Now, fundamental question is, as I said, anything that you want to do, some process, it should be loaded in your memory. Loading something into your memory can be done by operating systems. Operating system is nothing but software. Operating system is software like your application program. Both are all software. Only function is different, mission is different. But anyway, at the very first phase, how that operating system comes in this memory. Who brings the operating system into this memory? There's a big question, right? Operating systems, once the operating systems in this memory, then this, let's say this is operating systems, then this operating systems runs and take care of all the business. Perfect, fine, I like it. But the question is, at the very first time, how that operating system comes in this memory.
Isn't the BIOS not
That is something, yeah, here, Bootstrap program is loaded at the power up and reboot. When you turn on your computer, then Bootstrap. What is Bootstrap? I have boots here. So if you have a boots, then there's a Bootstrap back so that when you wear your boots, boot is long, right? It's not like the sneakers. Then you need to pull by pulling that bootstrap, pull it so that your foot can be inside the boots, right? That's a bootstrap. So there's some small piece that can lead the rest. That is called the bootstrap. It's a small piece of program that is always available. Where? In the ROM. ROM is not in RAM. The memory usually is RAM, right? This is RAM. Random access memory. That's called the RAM. But Bootstrap is stored in ROM or EPROM. Like EPROM, then Arduino Uno, it has EPROM. In that EPROM, that operating system is already printed and it protected. It's not erased. It's a manufacturer printed Bootstrap, small program that is a software program. That what that program can do is that bring operating system in the memory. Once that the Bootstrap brings operating system in this memory, after that, then everything that can be taken care of by operating systems. So the mission of a Bootstrap is the simple things. Bring operating system in the memory. That's it. And then EPROM is done. Bootstrap, done. If you look at the boots, right? Should I draw boots? If you have boots, cowboy boots, this is cowboy boots. Then usually there is a bootstrap back here, right? Small piece bootstrap. So this bootstrap needs to be pulled up when you wear. This bootstrap doesn't carry you to mountains. Boots itself carries you, right? Bootstrap, mission of Bootstrap is not the mission of Boots itself. Same thing here, operating systems. So what Bootstrap program can do is to initialize all aspects of a system. It loads operating system's kernel and starts execution. So when you turn on your PC, at the same time, then Bootstrap runs, because that is this ROM is connected to your switch. It's directly connected to your switch. So it runs. Okay. So all the peripherals available here. And there is I/O devices and CPU, all. The last bullet points here. Device controller informs the CPU that it has finished its operating system by causing an interrupt. How your computer recognize when you plug USB? Sometimes your computer does not recognize it, right? Then you have to plug in back and forth until it recognizes it. Sometimes the port itself is not sensitive, then you have to, on the other side, from the other end, you have to scan through the device, and therefore you need to link your operating systems to that particular external device. But in general, to all certain things, all that events needs to be done by interrupt. CA interrupt. Actually, the event handlings can be done in two ways, by interrupt or polling. Interrupt or polling.
It's like break.
Polling means that I'm the computer, okay? I'm the CPU, okay? I'm the controller. Then polling mechanism is the following. I can say, do you have anything for me to do? Do you have anything for me to do? Do you have anything for me to do? I am polling every single devices that are available surrounding. That's a polling. On the other hand, interrupt. Somebody who needs my help, then interrupt me. But if I am so busy, then I may not listen. Then he keep interrupting until I recognize it. That is the way that you plug it in and back when you do USB. Okay. Same thing in the Ethernet. You guys network export. How your computer understand when email comes through the network, Ethernet cables. How your computer, how your network card understand that there is my email.
Is your email operation of unpacking, taking the package and unpacking it and using the application?
No, that's too high level. That's what we learned at network. My question is even a lot lower, like interrupt. More physics. How Ethernet runs. There's an Ethernet the port, so you connected it.
It's a signal. It's
Okay, signal.
electron by electron. It's a signal that goes. It's one that's moving the other one, and we receive a signal. That's why there's a communication.
Okay, similar. So signal goes one direction, or it goes back and forth?
It can go from
Back and forth. Then there's a collision. One signal goes. There's a one line.
But
There's not multiple lines. One line.
Window.
So a lot of
There's what's
collision.
called window. Before sending something, we send the window, and we say that we're able to send.
So if there's no nothing, there's no signals.
Say again?
If there's no mail, there's no signals.
There's always signals. There's
Always
pings.
signals. Then yeah, that's what I'm
When you
asking.
connect
So
to
how
there's pings.
how your network cards understand that there is an email? There's always a signal.
By the size of the
So you look at all the sizes. Okay, here's the things. Okay. Ethernet. How signals moves the Ethernet cables. There is a current, there's a power, there's a very small power, small current is running. Okay, we call that milliamp current is running. So let's say 0.08 milliamp, there's a normal signal. If there is no data, then 0.08 milliamp running. If there is a data, there's a signal, right? Data. Then that amps goes up, 0.13 milliamp. So by identifying the different amp, your network card, there's an interrupt. That little higher amp interrupt your network card. Then your network card usually slips, and there is a little bigger current comes in that, oh, take it. Oh, take it. Right? They're like an interrupt. So everything that way. That's a very, very physical, low-level interrupt. But interrupt here is more programming level of interrupt. When you purchase device, when you purchase mouse, for example, mouse is a device. When you move your mouse, then there is a one position to another position. Position change. That change positions needs to be notified. That is an interrupt. Okay? So position information needs to be notified to your operating systems. So that interrupt with that data, position data, needs to be provided to your operating system so that your operating systems, oh, there is an interrupt. Oh, by the way, this is a position change. Therefore, previously, see here, your mouse is here. When it moves to here, then it, oh, from that position to that another position. Okay? So, when you buy this device, if you want to do system programming, which means it's not application programming, it's a system programming, like operating systems. You build the operating systems. But if you want to build part of operating systems, which is to manage your mouse, then there's a lot of signals, a lot of specifications of signals. Hey, we have this kind of current comes in, then oh, this brings the position information. So that needs to be manipulated. We call that interrupt handling. Okay, so functions of interrupts. Interrupts transfers control to the interrupt service routine generally through the interrupt vector. So there is a list of interrupts, which contains addresses of all the service routines. So when you purchase and add new devices into your computer, then you need to add the new interrupt into that interrupt vector. That is a part of the installation process. Therefore, you need to install, right? Interrupt architecture must save the address of the interrupted instruction. A trap or exception is a software-generated interrupt caused either by an error or a user request. An operating system is interrupt-driven. It's not polling. What some operating systems do polling driven. Some missions of operating system is polling based, but usually interrupt driven. Your operating system is so busy, so external device needs to first initiate to interrupt your operating systems and wake him up to do some work. So interrupt handling is a polling and back to the interrupt, as I said. Yeah. So timeline of an interrupt. For example, if you have a CPU and I/O device. I/O device could be anything: your mouse, keyboard, monitor, or audio, or even network. Okay, user process X. So we have here missions. User process executing, I/O interrupt processing, and idle and transferring. So first I/O request, then I/O devices are idling. But because of there is a request, so transferring the signals. Then transfer is done to CPU. Then CPU got interrupt, so interrupt processed because there is some. The I/O says, "Oh, I want to send a message." Then CPU is ready to receive that messages. That type of things needs to be done. So between CPU and device, in between there is an interrupt. So I/O structure. After I/O starts, control returns to user program. This explains something about control and I/O, but it's not really. This slide, I think you already know, right? Kilobytes, the size of the data, and therefore we can now think of storage. So one of our operating systems' mission is to manage storage systems. So this slide explains about the different types of storage. So main memory. Well, actually, main memory is not for storage. Nothing can be stored if it is although available in main memory. If there is no power, then no more. Right? Data is not persistent if it is available in main memory. So it is not really storage. Main memory is more processing. But other than that, they are all storage, right? All the way up to solid state disk. So hierarchies, storage hierarchies. If you have a storage, then the factor of the storage, factors can be speed, high speed or low speed. Usually magnetic or optical storage is a low speed. Solid state is a high speed. Volatility, main memory storage is it's a volatile. It's not persistent. Okay. If you have a storage, then there is a program called device driver. Driver is nothing but a program, software that can handle your hardware. Okay. So when you have a new storage systems, then you need to install the software so that that software can do some a communication between your computer and the storage. Okay, like the printer. Printer has a printer drive. Okay, if you have a network card, then you need to install network driver. Okay, if you install new mouse, then you need to install mouse driver, keyboard driver, speaker driver, whatever.
Professor, the operating system cannot speak to the hardware directly. The driver is this communication between the operating system and the
Correct.
BIOS.
Mhm.
Then the BIOS speaks to the hardware with the firmware. Each hardware.
Right. So what driver can do is that your operating system does not understand the driver hardware itself. So driver contains all the specificities about that drive, that hardware. So that's what driver can do. And some of the protocols not known by your operating systems, if it is a brand new devices, then should be known by your operating systems. So a little bit of such things can be done in driver. But main communications and controls and management can be done your kernel operating systems, system level operating systems. This is storage hierarchies. You probably already understand. Okay, I think this is done for today. So next week, definitely we finish up operating systems. Okay, by next week, and then we will have maybe 2 weeks. That is for the database. There we did a little bit of database programming, right? We will do more. Okay, see you next week at that.